Hello, everyone. Today we're going to cover Chapter 4, Part C. We're going to focus on how to make a forecast when your data set is seasonal. So when your data set is seasonal, we're going to use a combination of the linear regression method and the seasonal factors to make forecasts. I'm going to take the following example and show you how to make a forecast. Suppose you are raising turkeys at a farm. You are selling them to local grocery stores. Given the quarterly sales data for the past 2 years, forecast the quarterly sales for the next 4 quarters. So in the first quarter of 2018, you sold 13,000 turkeys. In the second quarter, you sold 9,000 turkeys, etc. And we are at the end of the fourth quarter of 2019. And we want to make a forecast for the next 4 quarters. What steps should you follow? First, we want to identify the pattern of your data. So we're going to plot the data points on the XY plane. And the x-axis is going to be the time, and the y-axis is going to be the sales. But here is something you need to be careful about. When you plot something on the XY plane, the x value should be a number. But here, the time is expressed as the first quarter of 2018, the second quarter, etc. Right? You can't use these as x values. So we're going to relabel them. So these are the y values. So we're going to leave them as they are, but the x values should be relabeled. So we're going to relabel them as period 1, 2, 3, 4, 5, 6, 7, 8. And then we want to make a forecast for periods 9, 10, 11, and 12. And currently, we are at the end of period 8. So let's plot them on the XY plane. Now you can see that the x values are relabeled as 1, 2, 3, 4, 5, 6, 7, 8. And we want to make a forecast for the next 4 periods. And what pattern do you see in this graph? The over trend is increasing. And there's also a seasonal factor, seasonal pattern. So we're going to capture the over trend using the linear regression line. And then we're going to capture the pattern within a year using seasonal factors. And we're going to compute the forecast by multiplying the value on the regression line by the seasonal factor. So here's something we can follow. To capture the overall trend, we're going to use the linear regression line. How can you find the linear regression line? We're going to use the x and y values. The x values are these, and the y values are these, right? So we're going to go to Excel. So these are the x values, these are the y values, and we're going to go to data. We're going to click on data analysis, click on regression, click OK. Y range is, the y values are these. The x values are these. And I want my output here. And click OK. Then Excel says the regression equation is, this is the A, the intercept, 9.96. And this is B, the slope, 0.45. Yeah. So let's go back to the slides. Okay. So we found the regression equation. So next, okay. Now the next step is compute the y values on the regression line for the next 4 quarters. So how can you find the y value of this point? So we just need to take the regression equation and plug in the x value, which is 9. Right? If you plug in the x value, you get 14.032. That's the y value of this point. And then how about this? Again, plug in the x value, which is 10. You get the y value of this point. And likewise, plug in 11 and 12. So these numbers are the y values of these points. But are these our forecasts for the next 4 periods? No. What's wrong with these numbers? They don't show the seasonal pattern. They show the overall trend, but they don't show the seasonal pattern. So how can we make them show seasonal pattern? For example, this one is in the first quarter. What happens in the first quarter of a year? Let's look at what happened 2 years ago. In the first quarter, the actual demand is a little more than the overall trend. What happened a year before, last year? This actual demand was a little more than the actual demand, the overall trend. So do you think the same thing will happen this year? Probably. So if we can find out what percentage of demand is inflated in the first quarter of a year, we can use that to adjust this number, right? So to do that, we're going to use the seasonal factor. The seasonal factor will tell you what percentage of demand is inflated or deflated because of the time effect. And the seasonal factors are also called seasonal indices. So how can we reflect the pattern across the seasons? Use seasonal factors, and they'll tell you what percentage of demand is inflated or deflated because of time. And the seasonal factor is defined as follows. It's the ratio of the average demand within a season, within a particular season, to the average overall demand. So let's go back to the previous example. Let's say we want to compute the seasonal factor for the first quarter, right? So according to the definition, this is a ratio, right? Let's look at the lower part, the average overall demand. This is easy because we just need to compute the average of all the data points. We have 8 data points, just add them up, divide by 8, and you get 12. So the lower part is 12. How about the upper part? The average demand in the first quarter. So how many data points do we have for the first quarter of a year? We have 2 data points. We have the data point for the first quarter of 2018, and we have another data point for the first quarter of 2019. So you just compute the average of these two. 13 plus 14 divided by 2, you get 13.5. So the upper part is 13.5. Okay, so divide and you get 1.13. So that's the seasonal factor for the first quarter. Now we can repeat this for the rest of the quarters, right? How can we compute the seasonal factor for the second quarter? Again, this is the average demand in the second quarter divided by the average overall demand. The lower part is easy. It's just the average of all the observations, which is 12. And the upper part is the average demand in the second quarter. So how many data points do we have for the average demand in the second quarter? 2, right? You compute the average of these two, you get 9.5. So the answer is 0.79. And you can repeat this for the third quarter. Right? The only part that you need to change is the upper part. You need to compute the average of these two, the numbers for the third quarter, and also the fourth quarter. Okay. Now the next question is, how can we interpret the seasonal factors? For example, the seasonal factor for the first quarter was 1.13. What does it tell us? Now, can you say that 1.13 is the same as 1.13 over 1? Yes, right? So now let's recall the definition of the seasonal factor, right? The definition of the seasonal factor was the average demand in the first quarter over the overall demand. So if the overall demand is 100%, the average demand in the first quarter is 113%. So in other words, on average, 13% is more. On average, the demand in the first quarter is 13% more than the average overall demand. Right? So how about this? Seasonal factor for the second quarter was 0.979, and you can rewrite this as 79% over 100%. So if this is the average overall demand, the average demand in the second quarter is 97%, so which is 21% less than the average overall demand. So in other words, the demand in the second quarter is, on average, 21% less than the average overall demand. So this is what we just talked about. If the seasonal factor for a particular season is greater than 1, the demand in that period is, on average, the seasonal factor minus 1 times 100% higher than the average overall demand. If the seasonal factor for a particular period is less than 1, the demand in that period on average is 1.1 minus the seasonal factor times 100% lower than the average overall demand. Yeah. So far we computed the values on the regression line, and then we computed the 4 seasonal factors. So for example, the seasonal factor in the first quarter tells us that typically the demand in the first quarter is inflated by 12.5%, right? So using these, how can we make a forecast for the next quarter? How about if we inflate this number by 12.5%? That means, how about if we multiply this number by the seasonal factor, right? Then we get the forecast for the next quarter. How about quarter 10? Again, take the number on the regression line, multiplied by the seasonal factor, you get the forecast. Also, this times this is the forecast for quarter 11. This times this is a forecast for period 12. So the forecast is the overall trend times the seasonal factor. So if you plot these are the forecasts. If you plot them, you can see that they show the pattern, and they also follow the overall trend. These are the forecasts for year 2020. So this is everything we have for this part. I'll see you next time.